Hello everyone, welcome back to the channel. I hope you guys are doing great. So today we are starting with basic statistics. Now as you know, this is the first module of our course Data Science, a naive man's approach. And after this module, we'll have 3 more modules, that is R programming, modeling, and finally advanced modeling. Now each module is divided into different sections. For example, in this module there will be 3 sections. So first we'll look at the fundamentals of statistics, then we'll move on to probability and distributions, and finally we'll wrap it up with a look at the hypothesis testing. Now let's quickly take a look at the contents of section 1, that is fundamentals of statistics. So in this video we'll learn about data and its types, then scales of measurements, then definition of population and sample, then measures of central tendency, which is basically mean, median and mode. Then we'll look at the measures of position, which are quartiles, etc. Then we'll move on to measures of dispersion, that is standard deviation, variance. And finally, we will cover a few other important concepts such as covariance, correlation, outliers, noise, and standard error. So that is how our section 1 will look like. Alright then, let's start with the first topic, that is data and its types.
Now data is a record of any quantity. And we have already seen that there are 2 forms in which we have our data, structured data and unstructured data. Then we have variables. Now a variable is an attribute that describes a person, thing, place, etc. There are 2 types of variables, qualitative variable and quantitative variable. Qualitative variables basically depict a description or categorize the data into categories, and it is non-numeric, such as gender or feedback on a scale as good, bad and moderate, etc. And the qualitative variables are of 2 types. Nominal variable, that is used for labeling the data and has no order, such as gender, male or female. And the second one is ordinal variables, such as rating on a scale as good, average, bad, etc. Then on the other hand, the quantitative variables are the variables that can be measured and are numeric, such as sales data of a product, height of a person, weight of a person, etc. Again, we have 2 types of quantitative variables, discrete variable, anything that can be counted, such as number of TV sold, number of games won, etc. And then the continuous variable. The continuous variable can take any value within a range, such as weight or height of a person. For example, weight could be 75.6 kgs, 78.6 kgs, etc. So it can take any value within a range. Hence it is called continuous variable. So these were the types of variables. Now moving to the next part, we have 3 types of data. Univariate. This type of data consists only one variable. The analysis of univariate data is just the simplest form of analysis, since the information deals with only one quantity that changes. Example, age, weight, etc. Then the second type of data is bivariate. This type of data involves 2 different variables. The analysis of this type of data deals with the causes and relationships, and the analysis is done to find out the relationship among the 2 variables. Now the examples of bivariate data is the data of temperature and ice cream sales in the summer season. Then the third type of data is multivariate data. It is similar to bivariate data but contains more than one independent variable. For example, a company wants to see the impact on their sales by advertisement through different media such as TV, radio, newspaper, etc. So this is called as multivariate data. Now the next term is big data. Nowadays we hear a lot about big data. So what exactly is big data? Big data is also a data but with a huge size. It is a term used to describe a collection of data that is huge in size and yet growing exponentially with time. In short, such data is so large and complex that none of the traditional data management tools are able to store it or process it efficiently. Few examples are the New York Stock Exchange data. It generates about 1 terabyte of new data every day. Or you can take the example of Facebook. The statistics show that 500 plus terabytes of new data get ingested into the database of social media site Facebook every day. So you can imagine how big this data is. So that is the reason it is called as big data. Next we have scales of measurement. Basically we use scales to measure our variable. For example, we use a scale such as low, medium, high to measure consumer satisfaction. Or we use a scale of 1 to 100 to measure the performance of students. Now there are 4 types of scales of measurements that are categorized based on the parameters as shown here in the table. So here the scales are given on the left hand side. Then we have 4 parameters: classification, order, distance, origin. And in the last column, examples of each of these scales are shown here. So first scale is nominal scale. We have nominal scale which only is used to classify or labeling such as male or female. Then we have ordinal scale. Ordinal scale which has the same properties as nominal scale, but it has an order as well, such as ratings, ranking, etc. Then we have interval scale, which is like ordinal scale, but with an additional property of distance. That is, each point is placed at an equal distance, such as time, temperature, etc. And it also does not have a natural zero. For example, temperature of 0 degrees does not mean there is absence of heat. Lastly, we have ratio data, which has all the characteristics of interval data, but it also has a natural zero, which means it also has an origin, such as height, weight, etc. So this was in brief the scales of measurements. Then we have population and sample. So in statistics, we carry out a study on sample to derive at a conclusion about the population, because data on population in general is not available. So if you look at the definition, the population is the entire group for which information is required, and the sample is a part of the population which represents the population. So as you can see here, the population is the entire group and samples are part of the population. Now the numbers that summarize the population are called parameter, and the numbers that summarize the sample are called statistic, such as mean, standard deviation, etc. So for population, mean is denoted by mu and standard deviation is denoted by sigma. And for sample, mean is denoted by x bar and standard deviation is denoted by s. Let's move on to the next topic. Now we have measures of central tendency, which are basically mean, median and mode. Mean is the average value. Then median is the middle number of your data set when it is ordered from lowest to largest. And mode is the most frequent value. You can see the picture shown here on the screen. It shows the 3 measures of central tendency. After this, we have measures of position. Measures of position gives a range where a certain percentage of data falls. So in measures of position, we have percentile. Percentile is a measurement such that after the data are ordered from smallest to largest, at most p% of the data are at or below this value, and at most 100 minus p% of the data are at or above it. So let's say we have our axis showing minimum and maximum points. Now here we can see that p% of the data falls below it and 100 minus p% of the data falls above it. So this is what percentile means. After that we have 5-point summary, which is minimum, maximum and 3 quartiles. Quartile 1 is 25th percentile, which means 25% of the data is below it and 75% is above it. Then we have quartile 2, which means 50th percentile. It is also called median. So 50% of the data is on the left hand side and 50% of the data is on the right hand side. And then we have the quartile 3. It means 75% of the data is on the left hand side and 25% of the data is on the right hand side. We also have quartile 4, which includes 100% of the data. So these were the measures of position. After this, we have measures of dispersion. Measures of dispersion are also called measures of variation. So in this, we will only see the commonly used terms. The first term is standard deviation. Standard deviation basically tells us how far a data point is from the mean. The lesser the standard deviation is, the closer the points are from the mean. The formula for standard deviation is shown here. Here x is an observation, mu is the mean, n is equal to number of observations, and if we are talking about sample, then we will use n minus 1 instead of n. After this, we have variance. Variance is the square of standard deviation. Then we have coefficient of variance. It helps us find the relative variance in the data. It is given as standard deviation divided by mean. Let's look at one example to understand this. Suppose we have two data sets. Dataset 1 has standard deviation of 12 and mean of 80. Dataset 2 has standard deviation of 0.2 and mean of 0.5. Now by looking at these figures, can you conclude which standard deviation is better? Is 12 better than 0.2 or vice versa? Well, the answer is no. So to address this problem, we use coefficient of variation. We use the above formula and find CV1 for sample 1 and CV2 for sample 2 as 15% and 4% respectively. Now the advantage of CV is that we can compare it in absolute term. Hence we can tell that 4% variability is better than 15%, and we can conclude that sample 2 is better than sample 1. After this, we have range. Range is nothing but a difference between two extreme observations, and it is given by the formula xmax minus xmin. Lastly, we have interquartile deviation, which is given by this formula 1 by 2 into Q3 quartile 3 minus Q1 quartile 1. Now Q3 minus Q1 is also called an interquartile range. So these were the measures of dispersion. Now we'll move on to the next topic. The next topic will cover a few important concepts. The first is covariance. Covariance is often denoted by COV, and it describes the relationship between two variables. Let's say we have two variables x and y. So covariance of x and y is negative if one variable increases and the other one decreases, and it will be positive if both decreases or both increases together. The value of covariance could be anywhere between minus infinity to plus infinity. After that, we have something called covariance matrix. Covariance matrix gives us the information about covariance between the variables, which is shown by orange rectangular boxes. These are the values for covariance between the variables, and the values shown by the green boxes is the covariance within the variable. So this entire matrix is called as covariance matrix. Now once we know that the relationship between variables is positive or negative, then the next question is how strong the relationship is. So to know the strength of the relationship, we use something called coefficient of correlation. Coefficient of correlation is used to find how strong a relationship is between two variables. Its value varies from minus 1 to plus 1, that is strongly negative to strongly positive, and the value of 0 means no relation at all. Now the formula for COV, that is covariance, is given on the left hand side for population and sample respectively, and the formula for coefficient of correlation is given on the right hand side for population and sample respectively. Now you don't have to mug up these formulas, just take a look so that you are aware of it. All these calculations will be done by the software, so we should just be aware of this formula. Now again, the benefit of using the coefficient of correlation over covariance is that the value of coefficient of correlation lies between minus 1 to plus 1, and the value of covariance lies between minus infinity to plus infinity. So in short, covariance tells us the direction of the relationship, whether it is positive or negative, and coefficient of correlation tells us the strength of the relationship along with the direction. Now let's move on to the next concept. Next we have outliers. Now outlier is an observation that is at an abnormal distance from other points. So as we can sort in the below figure, there are two observations, minus 70 and 95, which are outliers. Because minus 70 is an extremely low value compared to other values, and plus 95 is an extremely high value compared to rest of the values. However, outliers are not always so obvious, and we use methods like box whisker plot, interquartile range, etc. to detect outliers. We will see box whisker plots when we will do exercises in R, but for IQR we can just see the formula here. These are the formula that we use to find the outlier using IQR method. So any point that lies beyond these limits will be considered as outlier. Then our next term is statistical noise. So statistical noise is nothing but random irregularity that we find in any real life data. They don't have any patterns and consist of errors and residuals. Now error could be due to false measurements or wrong sampling. So it is the difference between actual value and the measured value. And the residual, as the name suggests, is the remaining part. Basically, when we will do modeling in our upcoming modules, then we'll train our model on a part of our sample. Let's say 70% of the observation we use for training the model. And then we'll test the model on the remaining 30% of the observation. So residual will be the observed value in the test data minus the predicted value by the model. We will see this later on in the modeling in detail. So for now, just understand that residual is the difference between the observed value and the predicted value. Now the last important concept is the standard error. So what it tells us is that how far a sample statistic such as sample mean, standard deviation, etc. is deviating from our actual population parameter, which means population mean or population standard deviation. So basically, let's say we have standard error of mean. So it will tell us if our sample mean is say 10, then how far it is from the mean of the population from which we have taken this sample. Remember, we are studying the sample to conclude about our population. So we must know how accurate our sample statistics are. So that is the reason we use standard error to understand the deviation between the sample statistic and the actual population parameter. Now obviously, if you have a larger sample size, then the standard error will be less. And in statistics, you will come across terms like standard error of mean, standard error of median, etc. The formula is given below, but standard error of mean is the most commonly used term. So here in the formula, sigma is the standard deviation and n is the number of observations. Now that will be all from fundamentals of statistics. So let's quickly see what we have covered so far. Well, we learnt about data, and in data we learnt about variables and its type, different types of data. We also saw what big data is, and then we moved on to scales of measurement, where we saw different scales of measurements, nominal, ordinal, interval and ratio. And then we saw the definition of population and sample. Then we studied about mean, median, mode, which are measures of central tendency. Then we saw measures of position, that is percentiles, quartiles, etc. And then measures of dispersion, which are standard deviation, variance, etc. Then the last we concluded with few more important concepts such as covariance, correlation, coefficient of correlation, outliers, noise and standard error. Now I know guys, it's been quite a few terms that we have seen here, but these are just basics. And this entire module is filled with concepts and theories that we'll have to go through it once. But remember, we don't have to mug up all these things. We are just making ourselves aware of these concepts because it will form the foundation of our data science journey. And these are just few selected concepts only. Imagine if we were to study the complete statistics, how difficult it would have been. So we are not going to study the entire statistics. These are just few important concepts that are picked up, and I am trying to explain them in the most simplistic manner. So just hang in there, 2 more sections to go, and then we'll have all the statistical fundamentals with us for the rest of the course. So I hope you found the video helpful. I'll also try to put up the notes of the entire section. So whatever you will see in the video is there in the notes as well. Alright then, thank you very much for watching the video. I'll catch you up in the next section where we'll be discussing probability and distributions.